Well, this is my very short pitch. As it says right here, it's a short Explorer pitch. It's intended for when I'm talking to either the electrical maintenance team or the mechanical maintenance team or a mixed team. And this is the type of pitch that I would give as a follow-up to the static testing. So let's say we've already talked about the static testing. So here it goes. Well, dear audience, as we have seen before, the static tester deals with the insulation quality of the motor. And that test is done while the motor is on standstill, while the motor is turned off. Baker SKF, we have a complementary unit, and on that unit, we test the motor while it is running. That is what we call dynamic monitoring. Other people may call it online monitoring. What this unit does is you just connect it to the voltage and the current sensors, signals on the MCC. If it's a medium voltage motor, you connect on the low voltage side to the 110 and 5 amp connections. And what's the purpose of it? Well, let's turn the situation around. We have some people from the electrical maintenance team here. And so I'm just going to ask pointedly the question. So Dave, you're an electrician. If there is some kind of a problem in an application, right? And you know that there's a problem of the application, and I'm the mechanical guy. And I say the problem is electrical. What's your answer?
It's mechanical.
No, it's electrical.
No, it's mechanical.
The problem is the motor. What's your answer?
The problem's in the bearings.
Yeah, and we can keep this game up all day long. Actually, unless you guys are different than every other plant I've ever been to, you are getting paid to fight every day. And the difficulty is to find a solution. Now, why is that? I don't think that the mechanical team is a whole bunch of idiots. I don't think that the electrical team is a whole bunch of idiots either. Both teams are completely professional. The real problem is that neither one of the teams has the type of information in their hand with which the right decision can be taken. So what's really happening is that Dave, you being the electrical team, you see that there is some kind of problem, you cannot really nail what the problem is, and you do the whole barrage of tests that you can think of to ensure that the problem is not electrical. The mechanical team does the same thing. And if both conclude that the problem is not on their side, then the most reasonable thing to do is to just drop the grenade to the other side of the wall and say the problem is yours. Now what this technology does, what the EXP does, is it hands you, among many other things, it hands you one key piece of information. It tells you what's going on the shaft. And why is this important? Well, what's going on the shaft, the torque that is going on the shaft, the torque is demanded by the load. The motor cannot invent the torque. The motor is in a do or die situation. If a particular torque is requested, is demanded by the load, then the motor either can fulfill that request or the motor is going to stall. So granted the motor is running, then anything you see as a torque on the shaft comes as a requirement from the load. Now how do we use this? Well, we just connect safely on the low voltage side at the MCC. We take our readings, the Explorer shows the torque signature, and if there's anything wrong with the torque signature, then both the electrical and mechanical teams, they will agree that the problem is mechanical. However, if the torque signature is healthy, then both teams must agree that the problem is not mechanical and the problem is electrical. So what we have here is what my friend Drew calls, we have the judge sitting on the shaft. It just says the problem is to the right or to the left. So that's the one key argument that I'd like to convey. But of course the Explorer is not just that. The Explorer is not a motor tester. The Explorer, I think that the Explorer, the proper way to describe it is it's a motor system analysis tool. What is in the motor system? Well, the motor system is basically a link, it's basically a chain that has 3 links. The center link is the motor. Upstream of that we have the power quality, and downstream of that we have the load. Now many times the motor is going to be the weakest link and the motor is going to fail. We replace the motor, it's going to fail again. And it's a very reasonable, yet many times wrong conclusion to say that the problem is the motor. I mean, how many times do I have to replace the same motor, perhaps with different brands, and until I realize that the problem must be on the outside. What the Explorer does is it analyzes the whole system. It looks at how well the motor can fulfill the requirements from the load with what we're feeding to the motor. We have motor models in there that give us an automated assessment, balancing the negative effects of a poor power quality with the effects of partial loading. That's just as an example. We also take care of other problems, direct motor problems, like for example broken rotor bars. We find them extremely well, and we have many, many references of users that had and that still have high quality vibration teams. And after starting to use the Explorer, they saw that with this technology, they can diagnose at a much earlier stage problems very accurately, cage problems with the Explorer. There are many other capabilities that the Explorer has that I'm confident that are going to be helping you, but I just want to leave it at that to give you an overall understanding. The two things I really want to drive home with this little talk is the first one, the Explorer is not a motor tester, it's a motor system analysis tool, so it looks at the whole environment that may be causing problems. And the second one is, I'm pretty sure that a lot of the struggles you're having in the maintenance team is the discord between electrical and mechanical team. And to the best of my knowledge, the Explorer truly is the best instrument on the market that experience says it will alleviate that struggle. Thank you very much.